Okay, my little pre-cal pumpkins, we are going to look at some examples for transforming our trig equations. So this is on page 5 of your notes. So this is just a continuation of the transformation video. So let's look at our equation. So I didn't create a place in the table for you for this, but I am going to talk about identifying if you're in degrees or radians first, and then determining if there's a reflection. And what I'll do is I'll mark through the item in the equation every time we take care of something. That will help you determine what all you're looking for. All right, and because also, just keep in mind that we're doing this, we're going through the transformations and trying to understand them because it will help us graph them. So that's why we're going through all of this stuff. All right, so the very first one, we have y equals 2 sine theta. So the very first thing I'm going to notice is that I've got theta here. That means we're dealing with degrees. So when we get ready to graph, that means your x-axis will be labeled in degrees as opposed to radians. Okay, and if you'll notice, we do not have a negative anywhere in this problem, so there is no reflection. So we're going to jump right into the amplitude. This right here is the amplitude. So that tells me that my entire wave from very top to very bottom is 4, because from the middle to the top is 2, and from the middle to the bottom is 2. And then the period, of course, since there is not a value between sine and theta, that means that the period is going to be 360, so the same as the parent function. All right, the vertical shift, there is none, and there is no phase shift either. Okay, so the second example, we have y equals negative cosine 2 theta. The first thing I notice is that I am in theta, so I am dealing with degrees here. There is a negative in front of cosine. That means that there is a reflection. And then the very next thing I'm going to talk about is the amplitude. I want you to notice that the number in front of cosine is an understood 1, so that means the amplitude is 1. The period now, we've got a 2 right here, so that means the parent period of 360 gets divided by 2, so it's 180 degrees. There is no vertical shift and there's no phase shift. All right, example 3, I'm still using theta here, so I'm still in degrees. There's no negative in front of sine, so there's no reflection. The amplitude, since there is an understood 1 in front of sine, the amplitude is 1. The period, since there is no value between sine and theta other than 1, that means that the period is going to be 360, just like the parent function. And then, of course, I've got this negative 3 tacked on at the end. The negative 3 is not in parentheses, so that means that it is not a phase shift. That means that we are moving the whole graph down 3. All right, next example. I've got theta again, so I'm still in degrees. There's no reflection because it is a positive 3 cosine. The amplitude is 3. The period, since there's no value between cosine and theta, is again 360 degrees. The negative 1 here is not in parentheses, so there's no phase shift. It means that the whole graph moves down 1. All right, number 5. We have y equals 1 minus cosine 1/2 x. Notice there's an x here. That means we are in radians. And then my amplitude, of course, there is nothing between the negative and the cosine. Oh, I forgot one thing. Sorry, babies. Since there is a negative right here, it means we do have a reflection. Sorry. Okay, and now, of course, since there's an understood 1 in front of cosine, our amplitude is 1. The period, we have to talk about this. We are in radians now, so the parent period is 2 pi. So, because cosine and sine have the same period, we never have to worry about that. But since we have a 1/2 here, I've got to divide 2 pi by 1/2. And what that means is that I have 2 pi times the reciprocal, which would be 2 pi times 2, so 4 pi is going to be the period. All right, vertical shift. We actually have a 1 at the front of this. It's 1 minus cosine. That means we're moving up 1, and there is no phase shift. Okay, next question, number 6, or next example. We have 1/2 cosine 3 theta plus 2. Theta is, of course, telling us we are in degrees. There's no negative in front of cosine, so there's no reflection. The amplitude is 1/2. The period is going to be 360 divided by 3. And this plus 2 means we move up 2, no phase shift again. Okay, number 7, y equals -2 minus 4 sine theta. We are in degrees then because of that. We do have a reflection, if I can spell, because of that negative. The amplitude is 4. The period, there's no value between sine and theta, so the period's going to be 360. There is a vertical shift of down 2, and there's no phase shift. All right, number 8, we've got y equals -3 sine, and then parentheses. That's going to change some things for us. Okay, we are in degrees. Okay, so taking care of that theta right there. We do have a reflection because of the negative. The amplitude is 3. There's no value between sine and the parentheses, so the period is 360. We do not have a vertical shift, but we do have a horizontal shift this time, or a phase shift. That means left 45 degrees. All right, number 9, y equals sine 2 parentheses theta minus 30 degrees. We are in degrees, of course, and there's no reflection. The amplitude is 1 because there's an understood 1 right in front of sine. The period is going to be 360 divided by 2 because of this 2 right here. There is no vertical shift, but there is a phase shift right 30 degrees. Okay, and here's our last problem in our table. We have y equals 1 plus 2 cosine pi times, okay, our parentheses x plus pi over 2. All right, we are in radians because we have an x right here. We do not have a reflection because this is positive. The amplitude, of course, is going to be 2. The period is going to be 2 pi divided by pi, which is 2. It's just reducing. And then a vertical shift, we do have a vertical shift of up 1, and we do have a phase shift, which would be left pi over 2. Easy peasy, lemon squeezy. Alrighty, so this matching question here, let's go over this. We can use each of these letters more than once or not at all. So we are going to look at a description over here on the left. So let's look at this. Number 11, we have a phase shift of 10 degrees right. So what is that going to look like? Well, we're in degrees, so it's going to mean theta to the right minus 10 degrees. So we're looking for something like that in our equations. So, oh look, we've got one right here, and that is all. So it is just C. Okay, the next one is a vertical shift of -2. So that means that either at the beginning of our problem, we're going to have a -2 and then something else is going to be added to it, or there's going to be an equation with -2 at the very end. So we need to look at everywhere this is occurring. All right, so let's look at A. See this -2 here, and then it's -3, that's one. See B, where we have a -2 at the end, that is also that situation. And then C, we have -2 here, so C, and then it is not happening anywhere else. This -2 right here, notice it's being multiplied by cosine, so it doesn't count. All right, now we've got a period of 720. Okay, this can get a little tricky. So if we're in degrees, that means a parent function of 360 has been divided by something to give me 720 degrees. So we've got to figure out what the something is. So let's cross multiply here. And then when I divide by 720, I get that x, this reduces to 1/2. So I'm looking for an equation in which I have a 1/2 directly following the sine or cosine. And it has to be in degrees. So let's look at these. I have cosine of 1/2. It's in degrees. That's a win. Sine of 6, no. Cosine, nothing, no. Well, not nothing, but 1. Sine of 1, cosine of 1/2. That one works, but look, it's in radians. That doesn't qualify. Cosine 3, okay, that's it then. All right, the next one is a period of pi over 3. So again, we need to think in terms of the parent would be in 2 pi divided by something to give me pi over 3. So I'm going to cross multiply here. Divide by pi. Okay, so I'm looking for an equation with a 6 between directly following sine or cosine, and we're in radians, so let's look for something with 6. There's a 6 right there. We are in radians, so B, that works. And then, no. Okay, that's it. That's the only one. All right, so now we're going to look at amplitude of 3. So now we're looking directly in front of sine or cosine, and we're looking for a 3. We've got one here. Not here. We've got one here. Not here, not here, not here. Okay, just those two. All right, number 16, oscillating between -1 and 1. Okay, this one's a little tricky. So let's think about this. When we oscillate between 1 and -1, that means that we need to look for a situation in which our amplitude is 1, so the value directly in front of sine or cosine is 1, but also no vertical shift. Okay, because a vertical shift, if this whole thing moved up, then it would be oscillating between like 2 and 0 or something like that. So we want an equation without a vertical shift. So let me erase all this writing I've done here. So we want no vertical shift, and we want an amplitude of 1. So this does not have an amplitude of 1. This does have an amplitude of 1, but moves down, so that's a vertical shift, so that's not going to work. This does not have an amplitude of 1. This does, and there's no vertical shift, so D works. All right, this one does not have an amplitude of 1. This one does, and there's no vertical shift, so F. Hopefully that helps you think through these.